I want to talk about the way constructors work in an inheritance situation because there are some special behaviors that we have to be aware of. Otherwise, our code will not compile. You might have noticed that in my other inheritance videos, I've avoided using any constructors at all. That's because we hadn't gotten to this video yet. In order to make sense of this, you do need to understand how to extend a class, and you really need to understand how overriding works and that idea of a kind of an inheritance hierarchy that's used for method calls. But if you've watched those, let's go ahead and take a look at constructors. We'll use the bank account and checking account classes that we have been using up until now. And we're just going to ignore the other methods here, and we're just going to talk about the constructors. Recall that when you create a class, if you don't define a constructor, then the compiler is going to create one for you. It's just going to take all the fields and set them to some initial values like 0 or a null reference or something like that. So I've got those constructors shown on my diagram here, even though we didn't write the code for them. Now consider just the sort of generic line of code we use to create an object, to instantiate an object. So checking account is the class that we're dealing with. We're going to call it account1, and then we're going to use this new keyword with checking account constructor call. And again, I haven't created the constructor, but the compiler is doing that for me. Now, when we talk about overriding, we had just gotten used to the idea that overriding method calls take place from the bottom of the hierarchy and work their way up. But with a constructor, it's different. A constructor starts at the top. It starts with a superclass constructor, and it has to run that constructor no matter what. After it's run the superclass constructor, then it's going to go ahead and go on to any subclass constructors it finds all the way down the inheritance tree. Let's go ahead and take a look at and see how this looks in Visual Studio Code. Same old bank account that we've been working with and a checking account that extends it. The only changes I've made is I added a new test file for it, a new test program, because my old one was getting a little bit cluttered. And so this is just called test constructors, and it's got a main method with nothing in it. Let's go ahead and create a checking account object here. Checking account, account1 equals new checking account. And again, that's that default constructor call because I haven't defined a constructor of my own. And I will just print out the we'll get the account number from this. So system out print line account1 dot get account number, just so we have something that I can test and make sure things are working. So far, so good. Again, that's that null reference that I mentioned a moment ago. Since my default constructor doesn't know what else to put in that in these fields, it just puts a null reference there for that string. And let's go ahead and go over to the bank account and create a constructor. So public bank account, and we won't have any arguments here. A lot of people refer to this now as a default constructor, and this is where I get nitpicky. It's no longer a default constructor because I wrote it. So a default constructor really is what the compiler makes, but everybody calls this a default constructor since it doesn't have any parameters or arguments, excuse me. I'm going to not do constructor things with this here. I'm just going to have it print something out. So I'm going to have it print out bank account constructor. And then I am going to go to the checking account and I'm going to make basically the same thing. Public checking account, another parameterless constructor here. And I'm going to say checking account constructor. Save both of those, come over to my test constructor program here and give it a shot. Sure enough, it says bank account constructor first, then it says checking account constructor, then it says this null pointer that's from our account number here. So this is just confirming what we saw a moment ago, that unlike regular method calls, a constructor call works from the top down. Now, where the potential problems come in is when we talk about constructors that do have arguments. And so let's say I get rid of that parameterless constructor, that default constructor, and now I've got one that takes an account number, which is a string. When I go to instantiate an object, at first this looks okay because the checking account class does have that parameterless constructor still. But what happens is it comes in looking for this constructor in the bank account first, and it says, well, here's the only constructor I see, and it requires some information. I don't have that information, so I can't do anything here. The solution here is that our subclass constructor needs to specifically or explicitly call that bank account constructor and pass in the information that's needed. So let's go take a look at how to do that. Okay, so let's go over to our bank account and make this new constructor. So I'm going to say public bank account, and this time it's going to take a string. I'll call it account number like that. And all it's going to do is assign account num equals that parameter. Now, in the interest of speed here, I'm not doing all the other variables, but I really should be assigning values to all those. And now, at this point, we're still okay. My program should still run just fine because this quote unquote default constructor is still available. The problem is often we don't want or don't need to create that sort of default constructor there. And so now when I try and run this, I have a problem. It might be hard to see there, but it says implicit superconstructor bank account is undefined. It must explicitly invoke another constructor. So if the only constructor I have requires one or more parameters, then this checking account class doesn't compile because it doesn't deal with that piece of information that's missing. So the idea here is if your superclass requires parameters in order to create an object, the very first thing you have to do in your subclass objects call that superclass constructor. So remember we had that keyword super that we used in our overriding video. If we just put super with empty parentheses, that now refers to the constructor, and in that parentheses I can put I'll put in just 1, 2, 3, 4, 5 as my account number. That should now compile and run it. So we're going to kind of clarify or add some nuance to my description before. It's not that that it starts at the top and begins calling constructors from there. It's that the default constructor of the subclass is really calling that default constructor of the superclass first. And it does have to be the first thing. So if I take that line of code and I put it at the bottom, that doesn't work. It's going to say that it must be the very first statement in the constructor. Okay. Now, I don't have to use that sort of literal value, that constant value 1, 2, 3, 4, 5. I can, for example, make a new constructor that also takes a parameter. And I can just say super and pass in that account number. And that should work as well. And so now I can create a bank account by specifying that account number. I'll just say ABCDE. And if I run that, that works. ABCDE. Now, to be clear, I've got two constructors here. I don't need to have both of them necessarily. It's just a question of which way you need to call and create your objects. But the takeaway here is that if you have any requirement that the superclass constructor has parameters, gets some data, and you don't also provide a parameterless constructor, then your subclasses have to address that. They have to use this super keyword to call back and run that constructor in the superclass before it can go on and do anything else. It's a somewhat confusing concept at first. You get the hang of it pretty quickly. The error messages, once you start seeing them, you'll go, "Oh yeah, I forgot that I got to take care of that." So it's not hard once you get the hang of it. But if you have any trouble with it, reach out and let me know.